Today we're going to be looking at the equations of parallel and perpendicular lines. So the first thing we need to do is to review these terms, and they should be a review. Parallel lines are lines that never intersect. So in the coordinate plane, when you see them, they look like railroad tracks. So line 1 in blue and line 2 in green are parallel. Let's look at the equations of these lines. So we need to write the equation of each one of these lines and then see what conclusions we can draw about the equations of parallel and perpendicular lines. So here, to write the equation of a line given a graph, I need to identify two things. I need to identify the y-intercept and I need to identify the slope. So for line 1, I need to identify the y-intercept, which looks like it's at 3. And then I will identify the slope by picking 2 points on the graph where it passes exactly through the grid marks, and then count up and over. In this case, it's up 1 over 1, so my slope is 1 over 1, or 1. So then I put these two things together, and y equals mx plus b. Okay, y equals my slope, 1, which is 1 times x, and then plus your y-intercept. So the equation of line 1 is y equals x plus 3. Let's do the same thing for line 2, which is in green. First I need to identify its y-intercept, which looks like it's at -2. Then I will pick 2 points on the line that pass through the grid marks exactly, and use the slope, up 1 over 1, which is 1 over 1, or 1. So now I put the slope and the y-intercept together in y equals mx plus b. So y equals 1x, or just x, minus 2. So let's look at these two equations and determine what kind of conclusions we can draw. There's not a whole lot that I can tell about these two lines using just the y-intercept. There's not a whole lot of comparison I can do between 3 and -2. But there is something special about the slope of both of those lines. And in this case, the slopes are the same. Okay? So in parallel lines, your slope will always be the same. So let's think about why that would happen. Here, I'm changing it up 1 over 1, up 1 over 1. The same thing down here, up 1 over 1, up 1 over 1. Because these two lines are changing at the exact same rate, they are maintaining the same distance between them each time. So if this one goes up 1 over 1, to maintain that same distance, this line also has to go up 1 over 1, and then the 2 points would stay the exact same distance apart. Whereas if I change the slope, let's say this one went up 2 over 1, up 2 over 1, notice that the lines would eventually intersect. So parallel lines have to maintain the exact same distance between them, and to do that, they have to be changing at the exact same rate. They have the same steepness, they have the same slope. Okay? So conclusion number 1 is that parallel lines have the exact same slope. So now let's think about perpendicular lines. And if you remember, perpendicular lines are lines that intersect, but they intersect at 90-degree angles. That's what this little box represents. So line 1, which is in blue, and line 2, which is in red, are perpendicular lines. They intersect at a 90-degree angle. So let's write the equation of each one of these lines and see what kind of conclusions that we can draw. We do the exact same thing. We need to identify the y-intercept and the slope. Line 1 is a little interesting because its y-intercept is not a perfect integer. But that's okay. I can use my powers of estimation, and I can say that this is about 3 1/3, or about 3.3. To do the slope, because this does not land perfectly on the y-intercept, I'm going to choose 2 different points that are perfect on a grid mark. So that looks like this point and this point. They pass exactly through the grid marks. So this slope, I know it's negative because it's going downhill, so it's down 1 over 3. So it's -1 over 3. So to put these two together in an equation, I have y equals -1/3 x plus 3.3. So now let's do the same thing for line 2, which is in red. It does have a nice y-intercept on an integer. It's 2. So I'm looking for another place here. It passes perfectly through the grid marks. So I'm going to use these 2 points. So up 1, 2, 3 over 1. Okay, it's a positive slope. 3 over 1 is the same thing as 3. So I get y equals 3x plus, plus 2. It's a positive 2. So let's compare these two lines. Y equals negative 1/3 x plus 3.3, and y equals 3x plus 2. Again, y-intercept is not going to tell me a whole lot about these two lines, but the slope will. So let's look at the two slopes. I've got negative 1/3 and 3. And the first thing that I notice is that the signs are opposite. So that is the first thing to look for perpendicular slopes, is that one has to be negative and one has to be positive to have this nice intersection here. So the signs have to be opposite. And the next thing I notice is that the fractions 1/3 and 3, if I turned 3 into a fraction, are reciprocals. And if you remember, reciprocals are fractions that are, you turn it upside down from one another. So 1/3 is the reciprocal of 3 over 1, and vice versa. If these two things are true, if we have opposite reciprocals, okay, the signs have to be different, the fractions have to be reciprocals, then the lines are perpendicular. And this is just the symbol for perpendicular. Okay? So now that we have our background, this is where your notes pick up. So you're going to need to fill out the examples as we are going along. I filled out the notes part for you already. And so just to recap, parallel lines have the same steepness, which means they have the same slope. In a graph, these look like railroad tracks. And in an equation, they will have the exact same slope, the exact same number for m. To determine if lines are parallel, because sometimes we'll be asked, are these lines parallel, perpendicular, or neither? So to determine that, the very first step you have to do is to put both of the equations in slope-intercept form. Y equals mx plus b. Solve for y. Once you do that, you can easily look at the number in front of x. You can identify what m is, and then see if m is the exact same number, then the two lines are parallel. So let's look and see if example 1, if the lines are parallel. First thing I have to do is to put them in slope-intercept form. So I'm going to subtract 2x from both sides first. I have 3y is negative 2x plus 4. Divide by 3. I have y equals negative 2/3 x plus 4/3. We need to do the same thing here. To get y by itself, I'll add 6 to both sides. So I have y equals negative 2/3 x plus 6. They are both in slope-intercept form now, so I can look at the slopes. This one is negative 2/3. This one is also negative 2/3. Because they are exactly the same, these lines are parallel. In your notes, you will need to repeat this process with example 2, solve both of the equations for y, and then look at the slope. If they are exactly the same sign, same fraction, then the lines are parallel. If not, then they are not parallel. So go ahead and fill that example out in your notes. Now let's do the same thing to determine if lines are perpendicular. Remember, perpendicular lines, the slopes are opposite reciprocals. Again, we follow the same process. We have to put both equations in slope-intercept form so that we can look at the number in front of x, we can identify m, and then we can compare the slopes. If they are perpendicular, they have to have opposite signs, and they have to be opposite reciprocals. So let's check that out with these two equations. First thing I need to do is I need to put them in slope-intercept form. I'm going to solve for y. I'll subtract 3x from both sides. Then divide by 5. So y equals negative 3/5 x plus 2/5. Oh, I think that's a minus 2. Minus 2/5. Alright, here I'm going to add 5x. I have 3y is 5x plus 7 divided by 3. And then y equals 5/3 x plus 7/3. All I'm looking at though now is the slope. Are the signs opposite? Yes, they are. Are the fractions reciprocals, 3/5 and 5/3? Yes. It meets both criteria, so the lines are perpendicular. In your notes, you will need to do the same thing for the second example. Solve each one for y, and then compare the slopes. If the signs are opposite and the fractions are reciprocals, then yes, the lines are perpendicular. So now that we can identify parallel and perpendicular lines, we need to take this one step further and be able to write the equations of parallel and perpendicular lines. We've already done this once before because we used the exact same process that we did for writing linear equations. We use mix. So we need to identify m, we need to use the x and the y of the given coordinate, and then plug those into y equals mx plus b and solve for b. The only thing that's a little bit different when we want parallel or perpendicular lines is when we get to the identifying the slope part, okay? We look at the given equation and we find its slope, okay? And if it's parallel, we use the exact same slope for m. If we want a perpendicular line, however, we need to use the opposite reciprocal of the slope of the given equation. That's going to give us our perpendicular line. Okay, so let's try this and let us write the equation of a line passing through 2, 3 that is parallel, and I'm going to underline parallel so I don't forget, parallel to the line 5x plus y equals 2. The first thing I need to do is identify m. To do that, the first thing I have to do is what is the slope of the given line. To do that, solve for y. Subtract 5x. Y is negative 5x plus 2. So the slope of my given line is negative 5. Then I look here. Parallel means that I want the same slope. So my m is going to be the exact same as the m of the given equation. Okay? Now I need to do y and x. Y is 3. It's the y value of the given coordinate. X is 2. Now I just substitute my m, y, and x into y equals mx plus b. So 3 equals negative 5 times x, which is 2. I solve for b. Okay, negative 5 times 2 is negative 10. To finish solving for b, add 10 to both sides. So b is 13. Do not stop here. We have to finish with step 6. We combine m and b into our final equation. Y equals, you don't have to fill anything in for y or x, only m and b. So y equals negative 5x plus 13. So the equation of a parallel line passing through 2, 3 to 5x plus y equals 2 is y is negative 5x plus 13. Let's do the exact same thing, but this time let's look for a perpendicular line. Write the equation of a line passing through negative 1, 4 that is perpendicular. I'm going to underline that so I don't forget, to the line 2x minus y equals 12. First thing I have to do, what is the slope of the given line? Solve for y. I'm going to subtract 2x. Bring down the negative in front of the y. Y is not by itself yet. Got to divide everything by that negative 1. Negative divided by negative is a positive. Positive divided by negative is a negative. Alright, so now to identify m. This is why I underlined perpendicular. A perpendicular slope, if the given slope is 2, I need to do the opposite reciprocal. This is 2 over 1. The opposite reciprocal would be negative 1/2. Flip the fraction and flip the sign. So the slope that I'm looking for is negative 1/2. I want the perpendicular slope. Now I can finish identifying y and x. Okay, just use the given coordinate. Substitute for y equals mx plus b. So 4 equals negative 1/2 times negative 1 mx plus b. 4 equals negative 1/2 times negative 1 is positive 1/2. So then subtract the half from both sides. And b is 3.5. My final step is to rewrite the equation with m and the b that I found. So my final equation is y equals negative 1/2 x plus 3.5. Okay? Got to make sure that my slope is the opposite reciprocal. All right, that's all for parallel and perpendicular lines.